Welcome to this channel. Welcome back. We are looking at the combinations of homogeneous and non-homogeneous second order differential equation. Okay, I want to say you are in the right place at the right moment. The first thing to do as you are coming in, just begin to say "I." If this is your first time of coming to this channel, please begin to like, share, and subscribe. Okay, and I've said before that undetermined coefficient is not the only method to solve second order differential equations. You can also use variations of parameters, but you need to follow the instruction by the examiners. Some examiner will stipulate to use undetermined coefficients, while some will tell you to use variations of parameters. The first one, we have second differential minus 2 times the first differential plus 3y equal to what? Equal to 0. We are told to find the general solution. How do we do that? Okay, how? And that's what we want to do in this episode. Okay, we want to provide solution to your how. Okay, and please, as you are coming in, just begin to say "I" and begin to what? If you want to make a comment, you want to type your own questions, you need to subscribe to the channel. Okay, subscribe. Begin to share the links across the different platforms. Call your friends now to join us. Okay, we don't want to waste time. We want to go straight to the work. Okay, this is a combination of homogeneous and non-homogeneous. Okay, and this will be the final review of using undetermined coefficients. Okay, as we know, we don't need to talk much. This is homogeneous differential equation. Okay, we said before that your differential equation is of this form. If it's equal to 0, if your differential equation is equal to 0 of this form, we call it what? Homogeneous. This is homogeneous. Okay, so step 1. Our step 1 is to get the auxiliary equation of the differential equation. Get the auxiliary equation. Get the auxiliary equation of the what? Of the homogeneous equation. And that will be, we're going to use the standard equation. And this is the standard equation for auxiliary equation. And we're going to correspond this to the given differential equation. Okay? The attachment to your second differential is 1 here. So if you correspond it, that means A is 1. So 1 times R squared. That will be R squared. Okay? The first differential, okay, the attachment or the coefficient is minus 2. That means B is what? Minus 2 times what? Times this. That's minus 2R. And finally, the attachment to your Y is 3. And that is what? That is C. So that's equal to what? That's equal to 0. Okay? And don't forget I said that your R squared is your second differential. Your R is what? Is the first differential. Okay, this is a constant coefficient. I'm going to use a factorization method for this one. Let's try if it's going to work. Factors of 3. Factors of 3 is 3 and 1. What we have here is what? Is a plus 3. Okay? So how can we turn 3 and 1 as the factors of 3 to minus 2? How? We can say minus 3 plus 1. That will give us a minus 2. Okay? But when you multiply it again, will it give you plus 3? No. That makes the quadratic equation to be unfactorizable. You can't factorize it. And that will now call for using formula, using quadratic formula. And this is a formula. Look at your functions The variable is what? Is r. So we're going to have r equal to minus b plus or minus b squared minus 4ac over 2a. That's the quadratic equation. Let's quickly go to advertisements. Okay, I want to say you need a coach, you need a tutor, okay, that will undo your materials, that will coach you according to your materials. The tutoring or the coaching will be tailored to your material. You need a tutor, you need a coach, and you don't need to go far. Just check this description of this video and check my email and send me an email. Your A is the coefficient of your R squared. A is 1. B is the attachment to your R, which is a minus 2. B is minus 2. And C is what? C is a plus 3. So R is equal to what? This is minus 2. So minus minus, that's 2. Plus or minus. B squared, that's minus 2 squared. That's a 4. Now minus 4 times what? A is 1. Okay. And then C is a 3 over 2 times 1 minus 12 over 2. Okay. And this will give us 2 plus or minus square root 4 minus 8, that's minus 8 over 2. And then this will give us square root of minus 8. If you punch your calculator, it's going to give you an error. But this is an advanced class. This implies root 8 times what? Root minus 1. Root 8 times minus 1, that is the meaning of this. And root 8 is 2 root 2. You can check your calculator. And then the square root of minus 1 is imaginary number, is a complex number, is I. Okay, so we're having 2 plus or minus 2 root 2 times the I over 2. So, and this will give you 1 plus or minus root 2 I. So this is giving us a complex function. A complex function in the sense that we have the real part, which is the 1, which we call the alpha. The attachment to your R is the imaginary part. We have the imaginary parts. Okay. A complex number is a combination of the real parts and the imaginary parts. Okay. And this solution, this solution, the root of the quadratic equation, is giving us two distinct complex number. Two distinct complex number. Okay, so the alpha is the real part, is 1. The imaginary part is called the beta. Imaginary part is called beta. So beta is what? Beta is root 2. Beta is root 2. Okay, then we can get the solution. We can get y1, which has this formula. Y1 is cos beta, okay, and that will be equal to what? The alpha is 1, so we have this cos beta is root 2, so that's the y1. The y2 is also the same, e to power what? And then cos sine beta, that's root 2. So we've gotten the y2, we've gotten the y1. So we can get the general solution of the homogeneous, which will be equal to C1 y1 plus C2 y2. I will give you question 2. You also try question 2. Question 2 and put the answer in the comment section. Put your answer in the comment section. Second differential plus 4y equal to 0. Okay. It's not easy to combine it. The first thing we do is to get the auxiliary equation. get the auxiliary equation. Okay, and that will be equal to the fourth differential will be r to the power 4. Don't forget what I said, that the first differential is r, the second differential, whether this one or this one, is r squared, the third is r cubed, and so on and so forth, plus the 2r squared. The one that has no differential, you just write the coefficient of that, which is 1. Okay, so that's what we have. Then we can, these are r to the power 4, that will be r squared, you double that, plus what? Plus 2r squared plus 1 equal to what? Equal to 0. So this one will give you a perfect square, whereby you have r squared plus 1 or square, okay, equal to what? So it's going to be double. And if this is giving you a tough time, very simple. What you can do, if you don't know, you can just make the r squared, give it a letter, let it be a. So you're having a squared, okay, minus 2a plus 1. This is plus, so that is plus 2a plus 1 equal to 0. So if you do this already a perfect square a, so that will be a plus 1 times what? A plus 1. Okay, so if this one is r squared and then is squared, that means the meaning is that your a now, what we now do now, your a is what? Is r squared. Okay, you can replace that. That will be r squared plus 1. Replace the a, and then you have this. That's simple as that. Okay, that's simple as that. Then the next thing to do now is to begin to equate them to 0. So that will be r squared equals to what? Minus 1. And that will be what? R equal to plus or minus square root of what? Minus 1. And that's equal to plus or minus I. Okay, and this will be what? This will be twice. This will be twice. This is a repeated root. This is a repeated root. It's a repeated root. That means y1 is equal to, we don't have the real part. The real part is 0. Okay, the real part is 0. So when you have a complex function, it's going to give you e to power alpha times this, and then cos beta x. Okay, your beta is just the attachment to your I, which is 1 in this case. Okay, so alpha is 0, anything to power 0 is 1. So you just have your y1 have a cos. Your beta is 1, so you have this. Your y2 will definitely be what? If you do the same thing, that will be sine x. Okay, since it's a repeated root, then it continues. Y3 will be equal to what? Will be equal to x cos x, and then y4 also will be equal to what? X sine x, because you must have the cosine and you must have the sine function. Okay, the general solution will be equal to c1 y1 plus c2 y2 plus c3 y3, and then plus c4 y4, and then you begin to plug in the y's this, and that's finished question 3. That finished question 3. Okay, that finished question 3. Okay, that finished question 3. That finished question 3. Question 4, we have a third differential plus 2 times the second differential plus the first differential plus 2y equal to 0. Step 1, get the auxiliary equation. And that will be equal to the third differential, that's the r cubed. I've said the first differential is r, the second differential is r squared, the third one is r cubed, and it goes on like that, plus the second differential, which is r squared, plus the first differential, which is a single r, plus the one that has no differential, you just write the constants there. Just write the constant there. Okay, so we now have four terms. So you're going to pair the first two, pair the last two. Okay, and if you do that, R cube is common. R cube is common. Take it out. Then we have R plus 2. Okay, the second one is common, and then we have this. And once you factorize, these two must be the same thing. You pick one of that times the one beside it. This is a square, not a 3, but this is R square. So R square plus 1 equal to 0. So that's that. Then you can, the meaning of this is that R plus 2 is equal to 0. So R is minus 2. R is minus 2. I can call it R1. The second one, R squared plus 1 is equal to 0. So R squared is equal to what? Minus 1. So R is equal to, take the square root of both sides. That will be plus or minus I. Square root of minus 1 is I. Okay? So there's no real part in this place. We don't have the real part in that place. The real part is 0 in this case. So we can get the y1, we can get the solution for r1 equal to minus 2, and that will be e to the power minus 2 x. Okay, that's for the first one. And for this complex number, we're going to continue with the solution. Y2 will be equal to, once you don't have the real part, just is 0. That's that's e to the power 0 times x, which is 1, and then times what? Cos beta. My beta is the coefficient of I, which is 1. So that's times x. So this is giving you cos x. Then we can get the third one, y3, which is equal to what? Sine x. Do the same thing also, sine x. Okay. Then the general solution, either you write out yc or you write out this one. This is the solution of the homogeneous equation. That will be equal to c1 y1 plus c2 y2 plus c3 y3, and then you begin to plug in those values. To the channel, like, share, and subscribe. Okay, like, share, and subscribe. You can subscribe to the channel. So we're going to have c1. My y1 is what? Is e to the power minus 2x plus c2. My y2 is what? y2 is a cos x plus c3. My y3 is what? Is sin x. So that's what we have in that case, and that's the general solution for that particular for that particular homogeneous equation. Okay, so that's that on that case. As you're coming in, just begin to say begin to share the links of this video across your different platform. Begin to share the links. For my returning viewers, kudos to you. Thank you for coming on board. Just begin to share the links on your different platform. Call your friends also to join us. Okay. The thing is, you need to show commitment. It's simple. I'm saying it's simple, but some people it's very tough. The more you practice, okay, the faster your comprehension. Okay. Practice is the key. If you don't practice, you cannot understand. And that's why I told you to take your journals, your writing material along with you. So the more you are writing when the speaker is talking, some part will sink to you. At least you gain some certain percentage of comprehension. Okay, you understand some percentage, if not all, some percentage, possibly. Okay, by the time you now sit down again, you get the 100%, and then you do it over and over and over. You become a genius. So that's what we have there. So this will be equal to the first differential. Get the auxiliary equation. Get the auxiliary equation. Get the auxiliary equation, and that will be equal to r to the power 4 minus 1 equal to 0. Okay, and this will be equal to r to the power 2 square that minus 1. Okay, you can also make it to be of the same form, square that and square that. So this will be the difference of 2 squared. This is the difference of 2 squared. 1 to any power is still 1. So you begin to take one of these, r squared minus 1. Okay, r squared minus 1 part of that. And then again, r squared plus 1 squared equal to 0. Okay, note a squared minus b squared is going to give you a minus b times a plus b. A minus b times a plus b. So the same thing I apply also. Try to make this one a multiple, make this one also a multiple. Okay, but this one is a double multiple. So that's equal to 0, r squared plus minus 1, and this also is also a difference of 2 squared. Okay, that's why I put b is a difference of 2 squared, because this one is multiple, 1 also is also a multiple. So this will be equal to r minus 1 times what? R plus 1 equal to what? Equal to 0. So I'm going to have 2 there, r is equal to 1, or r is equal to minus 1. Okay, so you can quickly get the solution there. Y1 is equal to what? E to the power x. My r is 1, and then y2 is equal to what? E to the power minus x. Okay, so we've done the first one. We can go to the second one. R squared plus 1 equal to 0. This one is not a difference of 2 squared. Okay, the only thing you can do there is just to make the r squared have the subject. Make the r squared as the subjects. Okay, and that will be equal to what? R will be equal to plus or minus I. Plus or minus I. And then from there, you can get your third solution, which will be cos x, the alpha is 1. Okay, and then the fourth one will be what? Sin x. I think I've explained this over and over again. Solution, the final conclusion will be c1 times y1 plus c2 times y2 plus c3 times y3, and then the fourth one, I think we have 4 solution plus c4 times y4. Okay, and that will give you the complementary of the solution of the homogeneous equation will be equal to my c1, my y1 is what? Is this e to the power x plus c2, my y2 is what? My y2 is e to the power minus x plus c3, my y3 is what? Is cos x plus c4, my y4 is what? Sin x. Okay, sin x. So that's that on that question. Just begin to type place your hand on your keyboard, on your phone, and begin to say something. Okay, appreciate your energy. Okay, appreciate your dedication to this channel. Say something and begin to share the links, like, share, and subscribe. We have this question: determine the suitable. Look at this symbol. I'll tell you the meaning of that. A suitable particular solution to solve the following differential equation if the method of undetermined coefficients is used. Do not evaluate the constants. Okay, do not evaluate the constants. And we have the differential equation. We have the third differential minus 2 times the second differential plus first differential equal to what? T cubed, t to the power 3, t to the power 3 plus 2 times e to the power t. Okay, this is they told you the method to use the method of undetermined coefficients. That means that the differential equation is what? Is non-homogeneous, and you can see for yourself okay, the equation is not equal to 0. It's not equal to 0. Okay, that's what we have there. Determine the suitable. The meaning of this is to, the meaning of this symbol is to get the total YP, the particular solution. Okay, the total YP, because this equation, the function you have here, you have two different functions. This is a superposition principle we are going to apply, and we have discussed that today. We solved two questions involving superposition principle. If you missed that video, I will employ you to go there right now to go and watch it. A question, one of the students asked me, is the video recorded? It's on YouTube. Okay, it belongs to YouTube. Okay, so go there and watch superposition principle. It has been explained. Okay, it has been explained in detail. Endeavor to go there now and watch it. And as you're watching it, begin to share it to your friends and your colleagues. And don't forget to subscribe. Okay, so when you have non-homogeneous and you're having several effects being added together, we'll call it what? We're going to call it superposition principle will be applied. This question, the meaning of this symbol, okay, is a total particular solution. Okay, we for T3 is a function on its own. So you need to get the particular solution for this one. That'll be YP1. For the second one, is another function on its own. You need to get a particular solution for that also, YP2. So by the time you add them together, you superimpose them, then it will give you this function, this symbol. So that'll be YP1 plus what? YP2. Okay, the particular solution for the first function, and then the particular solution for the second function. And that's just the meaning of that symbol. For you to be able to get the particular solution, you need to get the what? The complementary solution or the solution of the homogeneous equation. Get your YH. Get the homogeneous solution. That's the first thing to do. That will help you to make a right judgment for finding the solution, for finding the YP of the respective functions. Okay, get the homogeneous equation, step one. Step one, get what? Get the homogeneous equation. That's the homogeneous equation. The left-hand side will be equal to 0. The differential equation aspect will be equal to 0. And then step two, get the auxiliary equation. Will be in form of, by the time you finish that, will be in form of quadratic equation. Will be in form of quadratic equation the moment you finish that. Okay, you have the third differential. The third differential will be r cubed, r to the power 3 minus 2 times the second differential. The second differential is the r squared, and then plus the constant coefficient, just the coefficient of your y. That's 1. Okay, it is not differential. It should just be the attachment to that point to y. Okay, with differential, it is fourth differential, that is r, second differential, r squared, third, r cubed, and so on and so forth. So that's what we have in this case. What can we do now? Okay, there's a little adjustment. This is our first differential. I made a mistake there. The first differential, that will be r for the last part. That's the first differential. Okay, 2 times the second differential plus the fourth differential, which is r. Then you can factorize, you can take the r out. Then you have this plus 1 equal to 0. Okay, and we can solve this one. This one, factors of 1 is only 1 and 1. 1 and 1. How do we use 1 and 1 to generate the middle number? So that will be minus 1. This one, 1 here, 1 here. That will be minus 1, minus 1. And the moment you multiply -1 and -1, you're going to have what? You're going to have plus 1. You're going to have plus 1. This will be equal to r equal to 0 or 1. And this one is repeated, is twice. So call this one R1. The second one R2, which is equal to what? Which is equal to 1. Okay, that's a twice. That's a twice. Okay. Okay, so that twice is a repeated root. So that's that on that case. Let's get the complementary solution or YH. Let's get that. For this one, it's going to be C1 times e to power 0 to power 0 times x plus C2 times this one. We're going to get two solutions here, y2 and y3, which is equal to the first one will be what? Will be e to power x plus C3 times what? X times e to power x, because the repeated roots, and that will give you C1 plus what? Plus C2 times this, and then this one also. Okay. So that's that on that case. Let's form that corporation. Okay, let's form that corporation to begin to say something. We want this section to always be interactive. Okay, I don't want to be the only one talking. So tomorrow I will just do little work tomorrow, and I'll just be listening to you. Okay, let's always bombard the comment section. Okay, I'm not saying to destroy the comment section. At least bombardment, I mean to begin to type something. That's what I mean by bombardment of the comment section. Begin to say something constructively. Okay, constructively. Okay, that's my bombardment. Okay, constructively, begin to say something. Okay, on the comment section. Let's make it the discussion to be going. Okay, ask question. Okay, some people used to do that. Ask question. Ask question. You can ask me, we're just talking. Why are you talking this way? Nothing in your hand. We will respond to you. The magic. Okay? Okay, we'll tell you the magic, the formula. Okay? So that's that on that case. And actually, one of the magic, there's no magic anyway. That's the bitter truth. There's no magic anywhere. Okay? There's no magic anywhere. These are the word consistency. I've been doing it over and over and over. No formula, no magic. Take it or leave it. It's a constant practice. Constant practice. Okay? There's no magic anywhere. It's what? As a result of what? Constant practice. Okay? That's just that. Okay? We are going to do something here. The third differential times this one times this one. We're going to split the right hand side into two parts. The first part is t to power 3, which is quadratic. We're going to get the yp1 for that one. We're going to get the particular solution for that one. Okay. So the second one is going to be this, the differential equation plus this one. Okay, equal to the second part. That's what? 2 times what? 2 times this. So the question now is that how are we going to get this particular solution? How are we going to get this particular solution? Okay, so once you get the yp1, you get the yp2, then you add it together, and that's what we are told to do, and that's the end of the question. That's the end of the question. It's going to be equal to yp1. If we check it, we are going to make yp1 is equal to this one, q, and that's a polynomial of degree 3, and that will be equal to what? A, and don't forget, it's a function of t. So we are going to write this. We're going to write the expression in form of t. That will be a this power 3 plus b t2 plus what? Plus a BT, plus a CT, plus CT, and then plus finally plus D. But that's not the conclusion. We're going to check the the auxiliary equation, the homogeneous parts, okay, and see if there's anyone that have the same form of these particular equation. Okay, we're going to check the homogeneous equation or check the auxiliary equation, and these are the auxiliary equation. R1 equal to 0 and R2 equal to 1. Okay, and the second root is a repeated one. If you check this up, YP1, there's a constant there. There's a constant there. Okay, and also in the auxiliary equation, we have R1 equal to 0. It's also a constant. And that one is giving us what? By the time we do it, it's giving us 1. It's a constant. Okay, there's a constant there in that place. So in that case now, it has a kind of conformity with what? With D. D is a constant there. D is a constant. But the R2 is having E. Is having E. So it's only R1 that doesn't have E. It's just a constant. Because of that, we're going to multiply that equation by T. We're going to multiply the equation by T. Okay? We're going to multiply the equation by T. So that's that on these. And I think we've done something like this before. So this is not the first time. I'm going to recap it again for those that are just coming in. So then you can open the brackets, and that will be equal to what? A. This one times this one, that's power 4. We don't even need to do that. Don't need to, just leave it that way. Then we go to the YP2. We go to YP2. The YP2, we have exponential, we have E. And one of the rules of undetermined coefficients is when you have E function, okay, the 2 is just a constant. First of all, you write the same function, A e to the power t. You won't put the 2 there. You will replace that 2 with a constant. Then you now go to the auxiliary root, or the homogeneous parts. Okay. Don't forget this E is having RT, but this R is 1 in this case. Is 1. So you go and check your auxiliary root. Is anyone that is 1 there? Check there. Is anyone that is 1? Yes, there is 1 here. As the second R is 1, and the repeated root. It's a what? It's a repeated root. And when you have a repeated root, you're going to multiply that function by what? T squared. You're going to multiply it by T squared. And that will now give us the solution they're asking us for. That will give us what? Close the brackets. And then plus the second one. Plus T squared. A times E to the power T. Your R is 1, so there's no need to put the R, just for explanation's sake.